Hey guys, this week, which would be week 7 and from being out of school curriculum, we are going to cover special right triangles. Now this is going to be the only lesson we cover this week because it is a more difficult lesson to grasp. So we'll go through the video notes together and then you'll have 2 assignments. The first assignment will be easier type problems and then the second assignment would be more challenging type problems. But I will do a few examples of each one to give you an idea, make sure you know how to do them. So again, we're covering special right triangles. So as you know, with them being right triangles, that means they have a 90-degree angle. And I'll explain in a few minutes what makes them special. So our objective today is students will learn the properties of special right triangles in order to find missing side lengths in 30, 60, 90 triangles and 45, 45, 90 triangles. So what I mean by 30, 60, 90 triangles and 45, 45, 90 triangles is their angles for the triangles. So here's an example of a 45, 45, 90 triangle where 2 angles are 45, and for it to be a special right triangle, one of them has to be a right angle, so it has to be 90 degrees. So that's what we call a 45, 45, 90. And then at the bottom of that page of notes, let me get this out of the way, is your 30, 60, 90. So one angle's 30, one angle's 60, and the other one's 90. So what makes them special, because of those angles, we have representations to represent what each side is. So if you let each side across from the 45-degree angles be represented by X, because if this is an isosceles triangle here, you got 2 angles that are the same. So that means this side and this side are equal to each other. So that means if I let this side be represented by X, then that side can be represented by X. And if you do the Pythagorean theorem, X squared plus X squared would have to equal X square roots of 2 squared. If you work it out, that's how it would end up being. So the representations for a 45, 45, 90 triangle is X, X for the legs, and the hypotenuse is X squared of 2. So let's say, for example, this side had a length of 2, then I could find those other 2 side lengths. If this was 2, then that would also be 2, because X would be equal to 2. And so then that would be 2, and then if X is 2, then I replace that X with 2, and that side would have the length of 2 square roots of 2. That's the gist of what's going on here. Now with 30, 60, 90 triangles, the angle that's across from the 30-degree angle, that's your side that's represented by X. The angle across from the 60-degree angle, that's represented by X squared to 3. And then the hypotenuse side, the one across from the 90-degree angle, is represented by 2X. This is true for every 30, 60, 90 triangle. And just like up here, these representations of X, X, and X squared of 2 will always hold up for a 45, 45, 90 triangle. Okay, sorry, my computer froze up for a second. So we're going to use those representations to help us find missing sides of special right triangles. So, continuing on with our notes. Sorry, I get notifications when I have emails. Continuing on with our notes. Here's a 45, 45, 90 degree triangle. The reason we know it's a 45, 45, 90 is because this angle's 90. We can see that with the box represented there. And they gave us this side was 45. So if you take, since all 3 angles of a triangle add up to be 180, if I took 180 minus 90 minus 45, then there would be 45 degrees left. So now we can see that that's a 45, 45, 90. So what I recommend doing right off the bat, before I even read any of the given information, is whenever I have a 45, 45, 90 triangle, I immediately write down those representations on the triangle. So for 45, 45, 90, the angle, or the side across from the 45-degree angle is represented by X. The other side across from the other 45-degree angle is represented by X. And then if you look back at our first page of notes, the hypotenuse side is represented by X squared to 2. I cannot stress enough, writing these representations down on your diagram is extremely important. So that should always be your first step. Alright, now let's look at the given information. In an isosceles right triangle, in this triangle here, leg AB, so AB is this side, is equal to 8, which they have that on our diagram. So they're saying this length is 8. And they want us to find side BT and find the distance from A to T. So they want us to find these two, this leg of the triangle and this hypotenuse of the triangle based on that information, based on the one side that they gave us. So after you've labeled each side what represents those sides for a 45, 45, 90 triangle, and we can see that we know this side is 8, then you set that 8 equal to what's representing that side. So I would do that out to the side, x equals 8. Now, if it wasn't already to the point where x was by itself, then I would have to work towards getting x by itself. But in this case, x is already by itself. We can see that it equals 8. So going back to these other representations, wherever I see an x, I replace it with 8. So this side would be 8, and this side, replacing that x with 8, you still keep that square root of 2 attached to it. Those are the lengths of those two sides. So side BT is 8, and side AT is 8 square roots of 2. So again, the way we set these up, or the way we solve these, step 1, based on what kind of triangle it is, this case was a 45, 45, 90, label the sides, what represents those sides based on that first page of notes I showed you. So x, x, and then the hypotenuse is x squared roots of 2. Then look and see what side do you know. We know this side is 8. Set that equal to what's representing that side. So 8 equals x. And then my goal would then be get x by itself. It's already by itself on that one. And then replace x with 8 for the other two sides and get your answers for the distances or those lengths of those sides. So this side, since it was just x, it's just 8. This side, since it was x squared of 2, then that's 8 squared roots of 2. And those are our answers. So let's do another one. In the isosceles right triangle, hypotenuse OY, so here's our hypotenuse. Hypotenuse is always across from your 90-degree angle. And they tell us that side is 10. They want us to find side OB and side BY. So looking at this triangle, it's another 45, 45, 90 triangle. So across from the 45-degree angle is our x, is represented by x. Across from the other 45-degree angle is represented by x. And then the hypotenuse is represented by x squared of 2. And again, that's just me getting that from my initial information here, where one side is across from the 45-degree angles are both x, and then the hypotenuse is represented by x squared roots of 2. And it'll be that way for every 45, 45, 90 triangle. So now that I have those representations labeled, I look and see, well, what side do I know? I know that this side is 10, so I'm going to set that equal to what's representing that side. So 10 equals x squared roots of 2. And then, unlike this one where x was already by itself, this one doesn't have x by itself. So my goal then is to get x by itself, and then once I figure out what x equals, I can replace the other sides with that amount. So to get x by itself, it's x times square root of 2 right here, so I need to divide by square root of 2. Divide both sides by square root of 2. Now, I will say this. In mathematics, they do not like for you to have a square root in your denominator. So I've gotten x by itself, but I have a square root in my denominator. So the way we get rid of that square root in the denominator is you multiply top and bottom by that same square root. Because if you have the same thing, if you're multiplying by something that has the same thing in the numerator and the denominator, that's basically like multiplying by 1. So, and whenever you multiply by 1, you're not changing the original thing, because anything times 1 just gives you that same thing. So it's okay for us to just do this, multiply top and bottom by square roots of 2. So when I do that, in the numerator I have 10 square roots of 2, and then the denominator square root of 2 times square root of 2 gives me just 2. It basically just eliminates the square root. And then last but not least, I need to reduce that fraction. Just kind of ignore the square root of 2 right now, and looking to the left, the number in front of the square root in the denominator, what can that reduce to? So 10 over 2, or 10 divided by 2, gives you 5. So that reduces to just 5, and then keep that square root of 2 with it. So putting that back with it, and that's what we get for x. So if x equals 5 squared to 2, that was my whole goal, was to get x by itself. Now I can figure out what those other two missing sides are. Now those other two missing sides are just represented by x by itself. So if I replace x with 5 squared to 2, that's the length of that side. This is also just by x, so that's 5 squared to 2. So that's the length of that side. So they were both equal to 5 squared to 2. So those are the steps. That's the steps you take to solve these problems. First step, label the triangle with what represents each side. So 45, 45, 90 triangles are x, and then the hypotenuse is x squared to 2. Then, whatever side you actually know the length of, set equal to its representation, and then solve for x. So that's what we did over here. Once you know what x equals, then substitute it back in to find your other missing sides. Those are the steps. So we've done a couple of 45, 45, 90 triangles. Let's do some 30, 60, 90 triangles now. So just as a reminder, let me switch it up. 30, 60, 90 triangles. Across from the 30-degree angle is your x side. Across from your 60-degree angle is your x squared to 3 side. And then your hypotenuse is 2x. This is the one that confuses people more often than not. And I think whenever we did a test in classes before, in years before, I always supplied the kids with these diagrams so that they didn't have to memorize these. But just remember, across from the 30-degree angle is your side that's represented by x. Across from your 60 is your x squared to 3 side. And then your hypotenuse is 2x. And what I recommend doing when you're doing the homework assignment is go ahead and put this at the top of your homework so you can make sure you remember that stuff so you don't have to memorize it. All right, so let's go ahead and do some 30, 60, 90 triangles. Okay, so on this one, we have a 60-degree angle here. That one's 90, so that means this one has to be 30 for all three to add up to be 180. And across from the 30-degree angle is your x side. Now, luckily in this case, they already labeled it x, but we're going to go ahead and I'm going to go ahead and put my x there anyway. And then across from your 60-degree angle is your x squared to 3 side. And then your hypotenuse, which means you're across from your 90-degree angle, that's your 2x side. Okay, so step one's done. We've labeled what represents each side. And then now we need to set the side that they actually gave us the length to. They told us that this is 12, equal to its representation. Let me draw a line so we don't get this work mixed up. So we've got 12 is equal to x squared to 3. Okay? Now our goal is to get x by itself. So since we have x times square root of 3, we need to divide both sides by square root of 3. So we end up with 12 divided by square root of 3 is equal to x, because those square root of 3's canceled out. Now, I cannot have a square root in my denominator, so I need to multiply both the numerator and the denominator by square root of 3 to eliminate that square root in the denominator. So 12 times square root of 3 gives me 12 square roots of 3. Square root of 3 times square root of 3 gives me just 3. We don't have the square root with it anymore. And then now covering up that square root, we need to reduce that fraction of 12 over 3. 12 over 3 reduces to just 4. So that's 4 square roots of 3 is our x. So if x equals 4 square roots of 3, we now substitute that in to our other missing sides. So here, this side is just represented by x, so that would just be 4 square roots of 3 for that side. And the other side, this y side, is represented by 2x. So we need to figure out what 2x equals. So that just means 2 times 4 square roots of 3. Well, 2 times, and you just multiply it times the number that's in front of the square root. So 2 times 4 gives me 8. So that's 8 square roots of 3. So that's how you do that first example for the 30, 60, 90. Just because we're kind of, no, I'll go ahead and do it. I'm going to go ahead No, I'll just do all three, but I'm going to need some extra paper because I'm writing too big and using up too much space. I'm going to get some notebook paper here. Bear with me. Trying to make it semi-clean. Not doing a very good job. All right. So for this next example, it said we have a 30, 90, so this one has to be 60. And I'm going to go ahead and draw this to separate. Okay. So for this one, remember, across from your 30-degree angle is your x side. Across from your 60-degree angle is your x squared of 3 side. And then your hypotenuse is your 2x side. So once you have those representations wrote down, then you know, go ahead and set the side that they tell you the length of, which this side is 5, equal to what's representing that side. So that's x equals 5. So since x equals 5, x is already by itself, so we don't have to worry about getting x by itself. We just got to substitute that in. So this one actually isn't so bad. I don't need so much room for that. So if x equals 5, then when I substitute that in for the other sides, for this side here across from the 60-degree angle, I just replace the x with 5. So that becomes 5 squared root of 3 for that side. And for the hypotenuse side, that's just 2 times 5, because you're replacing that, substituting the x, or 5 for x, and you get 10. So the side that was labeled C, that ends up being 10 for its length, and the side that was labeled B is 5 squared root of 3. Alright, I guess I didn't use that extra paper. I'm going to go ahead and draw a line to separate these. This side is B. It's marked right there, I just separated it. Alright, so first step, label your angles. They told you this one's 90, that one's 60, so this has to be 30. And then label the representations for each side. So across from your 30 is your x side. Across from your 60 is your x squared of 3 side. And across from your hypotenuse, which is across from your 90-degree angle, is your 2x side. Okay? So the side that we actually know the length of, they told me this side was 5 squared root of 3. So I set that representation for that side, x equal to 5 squared root of 3. Now, x is already by itself, so we don't have to worry about getting x by itself. We just got to substitute in 5 squared root of 3 for these other x's here. So B, side B, was represented by x squared root of 3. So when I substitute in 5 squared root of 3 for that x, that means 5 squared root of 3 for that x there, and then bring down that other square root of 3 that went along with it. Okay? Now, when you have square root of 3 times square root of 3, that gets me, it's basically just multiplying the two numbers underneath the square root. So that would be, end up being square root of 9, and square root of 9 is just 3. So basically, we've gotten rid of the square root for that. So we have 5 times 3, giving us 15. So this side is 15. Go ahead and label it over here as well. And then our last side, which was W, is represented by 2x. So that means 2 times 5 squared root of 3. Now, since the 2 doesn't have a square root with it, we just multiply that 2 times the number that's in front of the square root. So 2 times 5 gives me 10. Bring down that square root of 3. So that side W has a length of 10 squared root of 3. I know this is a lot to take in. That's why I'm really making this the only lesson for this week. I am going to do a few more examples with you just to get some practice, and then I'll assign you the homework. And what I'll do this week is, like I've done before in class, I'll make a key where I've done half the problems and post that up on It's Learning. So as you're doing the homework, if you're running into questions, you can look up that key on It's Learning. All right. And I'll again post these notes after I filled them out on It's Learning as well. So if you miss anything, you can get it from that as well, or you can rewatch the video. All right, so this page still says it's notes. It's just examples. It's just some practice. Okay. Up here, it's just reminding you, they used A's instead of X's. I always tend to use just X's for my representations. Any variable will work, but I always use X, X, and then X squared of 2, and then X, X squared of 3, and 2 times X for my two representations. But just understand, don't be scared because they told you A's instead of X's on both of those. And then each one of these is just, so here's the representations, and then here's an example that they gave you and showed you how to solve. Here's the representation for a 30, 60, 90, and then here's the example they gave you. All right, so what we're going to do is we're not going to do all 12 of these examples. We'll just do a handful of them, okay? All right, so number 1, we have a 45, a 90, so that means this angle also has to be 45. And just like we noticed up here, across from the 45-degree angles is our X side, so this is X, and this is X, and then the hypotenuse is X squared of 2. Okay? So across from your 45-degree angles is your X's, and across from your 90-degree angle is your X squared of 2 side. Then from there, you're just setting the side that they already told you what the length was, the 6, equal to its representation. So if X equals 6, now X is already by itself, so all we got to do is substitute in that 6 for the X's on the other sides. So that means this side is 6, because it just has X, and that means this side is 6 squared root of 2, because that representation was X squared root of 2. It's just substituting in 6 for those wherever you see an X on the other side. And that's all I really needed to show on that problem. There wasn't a whole lot of real work to it. Number 2, that's a 60-degree angle, that's a 90, so this has to be 30. Across from the 30 is your X side. Across from your 60 is your X squared of 3 side. And across from your 90 is your 2X side. So on this one, this is the side that they give us the length of, 10. So we set it equal to that 2X. And then you work towards getting X by itself. So divide both sides by 2, and we get X equals 5. Now that I have X by itself, I can substitute that in for the other sides. So wherever I see an X, I replace it with 5. So that's 5 squared root of 3 for that side, and the side is just 5, because it was just X. Number 3, we have a 45, a 90, so this has to be 45. Across from your 45-degree angles, represent by X, and across from your 90-degree angle is X squared root of 2. Now I need to set the side that we actually know the length of equal to our representation for that. So 3 squared root of 2 equals X squared root of 2, and then get X by itself. So divide both sides by square root of 2. And when we do that, these square roots of 2 cancel out, these square roots of 2's cancel out, and we're left with X equals 3. So now I can just replace both of these sides, replace the X with 3, replace this X with 3, and so those other two missing sides are both 3. All right, let's do a few more. So in this one, we have a 60-degree angle, a 90-degree angle, so this has to be 30. Across from the 30 side is our X side. Across from the 60 is our X squared root of 3 side. And across from our 90-degree angle is our 2X side. And the reason I go fast through that is because I've done it for years and years. So again, if I go too fast, pause it, catch up, rewatch it, do what you got to do. All right, so the side that we know is this side, which is 6. So we set it equal to its representation. So X equals 6. X is already by itself, so I just got to substitute that 6 in for the other sides wherever I see an X. So this side becomes 2 times 6, which gives me 12. and this side becomes 6 square root of 3. There's nothing more to do for that side. For number 5, we have a 45 and 90, so another 45-degree angle. Across from each of the 45-degree sides are our x's, and then the hypotenuse side is x squared of 2. Now, if you can naturally just see that 2 square roots of 2 equal to x square roots of 2, that x would equal 2, you don't have to show that work like what I did over here. But if you don't just naturally see that x would equal 2 then you can go ahead and set those two equal to each other. So x squared of 2 equal to 2 square roots of 2, and then divide both sides by square root of 2. The square roots of 2 cancel out, and we're left with x equals 2. So this side is 2, and this side is 2. I'm going to go ahead and skip number 6. It's real similar. I'm trying to find ones that might be a little not so obvious how to work them. Let's look at number 7. This ends up being a 45, 45, 90 triangle. So our representations are x, and for the hypotenuse is x squared of 2. So this is like that tougher ones. When I set these two equal to each other, the side that we know along with this representation, we have x squared of 2 is equal to 6. We need to get x by itself, so you divide by square root of 2. Whatever you do to one side, you do to the other. So the square roots of 2 on the left side here cancel out. I'm left with x is equal to 6 over square root of 2. Now I cannot leave a square root in my denominator, so I multiply the numerator and the denominator by that same square root. So we end up with x equals 6 square roots of 2 over 2, because square root of 2 times square root of 2 gives you square root of 4, and square root of 4 is just 2. So basically, if you're multiplying by the same square root, then when it's the same square root, it generally just gets rid of the square root, and you're just left with the number underneath. All right, and then last step on that, if I cover up that square root, 6 over 2 reduces to 3. So we get x equals 3, and then bring back that square root of 2. So x equals 3 square roots of 2, so wherever I see an x, I replace it with 3 square root of 2. Okay. Looking at number 9. Now they didn't tell us any of the angles, but they did tell us that these two angles are equal to each other and that that's a 90-degree angle. So that just tells us that for these two to be equal to each other, then they have to be the 45, 45, 90 triangle. Okay? Because 45 plus 45 plus 90 equals 180. All right, so from there, across from your 45-degree angles, those are your sides x, and then across from the 90-degree angle is your x squared of 2, setting x squared of 2 equal to 4. Divide both sides by square root of 2 to get x by itself. And again, we cannot have a square root in our denominator, so we multiply top and bottom by that same square root. So by square root of 2. When we do that, we're left with 4 square roots of 2 all over 2. And then cover up that square root. 4 over 2 reduces to 2. So our answer is x equals 2 square roots of 2. Bring back that square root of 2. Don't leave it up there. And then replace your x's with 2 square roots of 2. So this side is 2 square roots of 2, and this side is 2 square roots of 2. Let's go ahead and do number 10, and then we'll let that be our last example. So if this is a 60-degree angle, and that's a 90, then this has to be 30. Across from your 30-degree angle is the x side. Across from the 60 is the x squared of 3. And across from the 90 is the 2x. Whatever side they tell you the length of, you set it equal to its representation. So we set 6 equal to 2x, and then work towards getting x by itself. So I'm going to divide both sides by 2. We get x equals 3. So for this side, we replace that x with 3, so that side is just 3. And for this side, we replace the x with 3, so that side is 3 square roots of 3. Just thinking. Yeah, we'll go ahead and end there. All right, so what I want to do then is go ahead and look at our assignment. So on here, I went ahead, because they wrote it a weird way where they just, instead of saying like x squared of 3 and 2x, they referred to it as short leg, long leg, and hypotenuse, and then explained what represents each side over here. So I went ahead and wrote on your papers the representations for each side because it's less confusing that way. Then down here, you're given some examples. There's 9 problems. You solve for the missing sides. The missing sides are represented by A and B. And whatever you get for answer, let's say 1A, I would come down here, find that answer, whatever letter goes with it, and then down here, wherever I find 1A, which is right here, whatever letter went with my answer, I would put that letter here for this riddle. Okay, let's see what's... It says, use the answers to reveal the name of the team that Abraham M. Saperstein established and sent on the road in 1927. Now, if you Google that answer and get me the riddle, that's not going to be good enough. I want you to actually, you have to show me your work for these problems. Okay? All right, let's go ahead, excuse me. Let's go ahead and do a couple of these problems together, and then I'll let you finish the rest on your own. And we'll even do a couple problems from the challenging assignment as well, so that you can make sure you know how to do those. All right, so for number 1, across from our 30 side, we let be represented by x. Across from our 60 side, we let be represented by x squared of 3. And then across from our 90-degree angle, our hypotenuse side is 2x. And again, I just got that information from my representation up here, of my notes up here. And from the notes from our first page of our notes. All right, the side that we actually know is this side, and it's 5. So we set x equal to 5. X is already by itself, so I just got to substitute it in. So for this one, it's 2 times 5, which gets us 10. And then for this side, we replace that x with 5, so we get 5 square roots of 3. So for the answer to 1A, come down here, we got 10. So 10, sorry, I'm just scooch that. 10 goes with letter S. So for 1A, I'm putting the letter S in there. Okay? For 1B, the answer was 5 square roots of 3. Down here, 5 square roots of 3 goes with letter H. So for 1B here, I would put the letter H. Okay? I'll do one more of this page. Looking at number 2, we've got a 45, 45, 90. So across from the 45-degree angles, that's our x side. Across from that 45-degree angle, that's our x side. And across from our 90, that's our x squared of 2 side. So the side that we actually know is this side, which is 8. We set it equal to its representation. So we got x equals 8. Again, x was by itself, so I didn't have to do anything to get it by itself. But if you do run into problems where you have to solve for x, make sure you follow the notes that we did earlier to make sure you know how to properly do that. So in this case, since x is already by itself and it equals 8, wherever I see an x, I replace it with 8. So that side is 8, and the side is 8 square roots of 2. So for 2a, our answer was 8. So coming down here, 8 gave us the letter A. So for 2a, I put the letter A. Oops, there was, sorry, just notice, there's another 1b here, so that's H. I guess you got to check and see if there's any more 1a's and 1b's. Do not see any more 1a's or 1b's. So let's check and see if there's any more 2a's, which was A. Nope. And then 2b was 8 squared of 2. 8 squared of 2 is represented with letter R. So 2b is R. Let me just make sure there's no more 2b's. Nope, that's it. So that's how you attack this worksheet. That means you have the rest of the problems to do on your own and to fill out the riddle sheet. So this is the less challenging page. It's kind of like the intro to practicing on those kind of problems. This page here is more challenging type problems. It's like working with more than one of those triangles together. So let's do a couple of these together, and then I'll let you do the rest on your own. And this will be your only 2 assignments this week. So it says find the missing side lengths. Leave your answers as radicals in simplest form. So just like what we've been doing, radicals or square roots. So let's work with this triangle here first. The one that actually has a side length that we know of. That's the one you want to start with. I'm going to put a little 1 into that triangle and a 2 in this one. So this is the one we're going to start out with on solving. So I'll put the work with that. And then once I'm done with that triangle, then I'll move on to that triangle. The side that they want your final answer to be is the side that they have the X for. Okay, so that's the answer they're looking for. Okay. So for the first triangle, we have a 45, 45, 90. Across from my 45-degree sides, we have X and X. And then across from our 90-degree angle side is our X squared of 2. So this is the side that we actually know the length of. So I set X squared of 2 equal to 10. And I got to solve for X. So I'm going to divide both sides by square root of 2. My square roots cancel on the left side, so I'm left with X is equal to 10 over square root of 2. Now I cannot have a square root in my denominator, so I multiply top and bottom by square root of 2. And that gets me X equals 10 square roots of 2 over 2. And then when I cover up that square root, 10 over 2 reduces to 5. So that's 5 square roots of 2. So if X equals 5 square roots of 2, wherever I see an X, I replace it with 5 square roots of 2. So this side is 5 square roots of 2, and this side is 5 square roots of 2. Okay? Now, I've got that all figured out. Now I got to work with the other right triangle here. It's another 45, 45, 90. Across from my 45-degree angle sides, those are X, which I already have. That one is represented by X, and then X, and then this would be X squared of 2. So the side that we actually know the length of is that 5 square roots of 2. So I'm going to set X squared of 2 equal to 5 square roots of 2. And then to get X by itself, divide by square root of 2. My square roots of 2 cancel out on both sides, and I'm left with X equals 5. So that means this side is 5, and this side is 5. And this is the side that they were wanting us to find. So our final answer for that is X equals 5. So that's a lot of work for a single problem. So I'm not going to give you too many of those. I'm going to do one more with you, and then that leaves 4 problems for you on your own. I'm going to go ahead, instead of doing number 2, I'm going to jump down and do, all of these are 45, 45, 90 triangles. Not a single one is a 30, 60, 90. Just FYI. I'm going to go ahead and do number 6, okay? So across, this is this triangle that we actually know the length of. So we're going to start with this triangle here. So this would be my first triangle. This would be my second triangle. So I've got, and if you need more room to work, again, I highly recommend just grabbing some notebook paper, doing your work on that. You can take pictures of that and send it to me. So for the first triangle, in fact, I might go ahead and do that. No, I'll do it on here so you guys, when I upload it, you can see it. All right, so I'll put it down here. Number 1, we've got a 45, 45, 90 triangle. Across from the 45-degree angle sides, we get X and X. And then this side, the hypotenuse is X squared of 2. Okay, so the side that I actually know is this side. Okay, so we set it equal to that. So x squared of 2 equals 9 squared root of 6. And then you work towards getting x by itself. So I divide by square root of 2, divide by square root of 2. We get x equals 9 square root of 6 over square root of 2. Again, we cannot have a square root in our denominator, so we multiply top and bottom by square root of 2. Sorry, my handwriting got a little messy there. I'm going to continue this over here. X equals 9 square root of 6 square root of 2 all over 2. Now, we need to simplify that. You can't have two square roots next to each other like that. So what you're doing is you're multiplying. So it's just like multiplying the two numbers that are underneath it. So we've got 9 square root of 12 all over 2. And we didn't really talk about how to reduce that fraction, or to simplify that square root. I kind of wish I would have, but oh well. It ends up being, I don't like this one for you guys because I end up skipping how to fix it, how to simplify those radicals. It ends up being the same thing as 9 times square root of 4 times square root of 3. Because remember, just like 6 times 2 gets you 12, so does 4 times 3. But that square root of 4 is just a 2 without a square root. So that becomes 9 times 2 times square root of 3, which gives you 18 square roots of 3 over 2. And then you would reduce that. Covering up the square root, you've got 18 over 2 gives you 9, so you get 9 square roots of 3. And that was what x equaled. Sorry, that was a lot. That was kind of messy. If you went into a problem where it gets like that, I would just scrap it, exit out, and just move on to a different problem. I would rather you not have to go into all that work. I'm going to go ahead and finish this problem just because I've started it, but because I didn't teach you how to simplify radicals, it's something you would have already learned previously, years back, but since I'm not reviewing that, I don't want to give you problems where you have to do that. So I'm just going to go ahead and move on. So x equals 9 square roots of 3, so that means this side is 9 square roots of 3. This side is 9 square roots of 3. And this just ends up being an ugly problem. We're just going to go ahead and scrap that. So just kind of ignore number 6. I don't like that problem for you guys. It's getting too complicated for what we're working with. I'm just double checking over the rest of this work here. And sorry. I don't think anything else gets complicated like that out of this. If it does, when I make my key, I'll be sure to say skip so-and-so in these problems in my email to you guys. All right? So just go ahead and do these other 4 right here on this page, and that's all I'm asking you to do on that assignment. So your assignment this week, finish this one, do the other 7 problems we didn't get to, and on this one, do these 4 that was left on that page. And that is your assignment for week 7. If you have any questions, I'm here. Just email me, or you can join our team meetings that we have on Thursdays and Fridays through Microsoft Teams. I always put the link on It's Learning, so you just got to click on the link to those meetings. For our geometry meetings, they go on Thursdays and Fridays from 1:30 to 2 o'clock in the afternoon. Have a wonderful day and stay safe.